Good morning. You listen to FloorDaily.net, and I'm Kemp Harr. This morning, my guest is George Donnelly, who's the owner of George Donnelly Testing and Inspections. George, how you doing?
I'm doing fine, Kemp. How are you?
I'm good. We were together last week at the Fuse meeting in San Diego, some wonderful weather down there, caught up, and we were talking about this issue with 1L concrete that we'll get to in just a minute. So a little bit of background. You've been an expert in the flooring business for most of your life. I think you actually started out in the franchise carpet cleaning business. That evolved, and you learned more and more about moisture and how moisture can pass through concrete, and that's your expertise. You're based in Arkansas. You have two other folks that work with you. You've built quite a business as an expert that can actually testify because you know all of the ASTM standards and all the solutions for trying to keep water away from the flooring.
That's what I try to do. I'm actually a member of two ASTM committees, Committee F6 on resilient flooring and Committee E6 on building standards. So F6 is the committee that not only writes the standards for the materials, but also is responsible for all of the testing standards that we use for moisture and alkalinity. E6 is a wide-ranging committee. My membership is because that is the committee responsible for the standards for subslab vapor retarders and their installation.
So let's talk about this 1L concrete. First, tell us a little background. Why is it even out there? It's also called Portland limestone cement. Tell us about it.
Well, we go backwards here a little bit to the Paris Climate Accords a number of years ago, where leaders from around the world decided that they needed to see a reduction in carbon emission from the production of cement. Production of cement, because of the heat required, is responsible for somewhere between 7 and 8% of the CO2 emission across the world because everybody uses cement. What wasn't discussed and is a frustration for me is that once cement is put into concrete, it actually absorbs carbon dioxide for its entire life. That's the process of carbonation. So there is a natural offset. Somehow that got ignored, and it was decided that we needed to find materials to replace some portion of the cement. So the type 1L, which is a limestone combination, is just the first in what is coming. There is an ASTM standard C595, which deals with all kinds of combinations of hydraulic cement with other mass materials. So there's a type 1P, which is a pozzolan, a type 1S, which is a slag, and then a type 1T, which is a combination of limestone, pozzolan, and slag. I'm not seeing those in the field yet. We're seeing type 1L out in the field, but the others are coming. And in fact, I just read an article that there's some research in Europe that they're trying to replace 100% of the Portland cement with a magnesium product. So the world is going to change dramatically for floor covering contractors because nobody's testing how we stick anything to these things.
That's the issue. You told me at breakfast the other day that the issue with this concrete is that it retains water and it takes a lot longer for it to cure. So tell us in more technical terms what's going on here.
When we look at limestone, here again, just a little bit of in the weeds of limestone itself as compared to other materials. If we look at quartz or granite, particularly the absorption of those materials is less than 0.5% of their own weight in moisture. So they don't hold moisture. We put them into the concrete and they don't have an effect as far as moisture content or moisture usage, if you will. The 1L limestone, relative to where it comes from in a quarry, can absorb up to 3 to 5% of its own weight in moisture. So the water demand on the production of concrete using 1L is greater. That water is absorbed into the limestone, and it slowly then releases that water back into the cement, which is going to dramatically retard the drying of the concrete. There are some people out there saying that we need to just plan to mitigate every slab. That's going to go over not probably very well at all.
So it's 28 days you can get on concrete, but with this 1L concrete, it's almost double the time, right?
Now we're talking about curing rather than drying. So just a quick discussion there. The curing of concrete is the chemical reaction that turns our materials into the man-made agglomerate we call concrete. That is a chemical reaction. Anybody that has been out on a job site where concrete was poured and actually touched the slab, it's hot. That heat is the heat of the reaction that is causing the material to cure. Drying is then the release of all the water that was not used in the curing and placement of concrete. So they're diametrically opposed. Curing requires all the water we can keep in there. Drying, of course, is the release of the water that otherwise is going to interfere with the floor coverings. And this is going to take longer to cure, and yet even that, I'm seeing people that are saying that it cured just as quick, others saying it cured much more slowly. And in my opinion, that is due to limestone quarries all over the United States delivering somewhat different material, because limestone is a sedimentary rock. So, for example, if you go to California, where we just were, there's a lot of limestone in those hills, but it is relatively young limestone placed when that area was underwater. It's seashells, etc., hasn't been compacted, can't be used for anything. On the other hand, there's a big quarry down in Texas that actually had a website for the quarry, and they actually explained the uses of the limestone from the various depths within the quarry. And of course, if we have a quarry that's deep enough with enough compaction, then the material we take out is called marble. So limestone across the United States is going to be different, and I think we're going to see different situations relative to where those materials come from across the country.
All right, so if you're a commercial contractor, you've been told it's 1L concrete, and we don't have time here to talk about all the different moisture testing, but you know you've got 1L concrete. So what's the solution for making sure the adhesive is going to stick and the floor will go down well?
And it's going to be that we'll have to do a significant number of bond tests across those slabs. Just to take it back or add one other step, saying that it's 1L cement in the concrete, that's one issue. But because this is also a very porous material, as I just said, limestone absorbs water, we're seeing densifiers put on the concrete. So I just printed a page this morning of one of the manufacturers, won't go into their name, and they're very proud of the silicate densifiers that they are pushing for 1L concrete. Well, now we're in conflict with ASTM F710 that says we can't install floors that have been treated with topically applied silicates. So it's not just the cement. People are going to have to learn how it was cured, whether densifiers were applied. And again, that's just all good background information. I don't want flooring contractors to have to be chemistry experts. But the easiest thing they can do is make sure they're doing a significant number of bond tests, moisture tests, and if it's 1L cement, I would recommend that they even put in their contract potentially a disclaimer against latent moisture-related bond failures, where that moisture comes out of the limestone and creates a moisture condition that they couldn't predict. So there's a lot to be considering, unfortunately.
So there's not a remedy for, hey, this is 1L, so I better use this. It's too complicated for that, right?
It is, again, with the possible exception that I have to at least consider the commentary I've heard by some people saying just plan to mitigate every slab. We all know what the cost is going to be for that. So I can't see owners going along with it until they've had a failure, and then it may become more widespread. Failures tend to teach people lots of things that they never wanted to know.
Okay, George. Well, I appreciate you giving our listeners a little bit of an insight on what's going on with this 1L concrete. Again, we've been talking to George Donnelly, the owner of George Donnelly Testing and Inspections, and you've been listening to Kemp Harr and FloorDaily.net.